Chapter 7, Introduction to Space Geometry. This is part 2. Now, after talking about some definitions and some facts that are needed to be revised, now we will start talking about some axioms of space geometry. Now, the axioms are some statements that we will need them to be used in order to prove some theorems in space geometry. First one is saying that two different points in space determine a line. Even this axiom is known previously because we know that a line can be defined by using any 2 points. So also now we say for any 2 points, 2 different points, we can determine a line. Now if we have 3 points, but these 3 points are non-collinear, so those 3 points in a space determine a plane. Now 2 points which are different determine a line, but 3 non-collinear points determine a plane. So if you look at this picture, we see that point A, N, and supposed to be L, those 3 points are non-collinear, so they can determine to us the plane P. Even if we talk about point A, S, L, also these 3 non-collinear points can determine to us another plane. Axiom 3, saying in space there are at least 2 points on a line and there is at least 1 point outside this line. So in the space, any line which can be determined by at least 2 points, since we are talking in a space, so there is a third dimension, so there is another point such that this point is outside the line. Number 4, a plane which has 2 points in common with a line contains this line. Means that if we have 2 points in common in one line, so the plane that is containing these 2 points is containing the line also. Axiom 5, if 2 planes have a common point, then there is a common point passing through this point. The intersection, there is a common line passing through this point. The intersection of 2 intersecting planes is a line. Since we are talking about 2 planes here, so this is the picture, and we say that the intersection of 2 planes is a line. Axiom 6, in space outside a plane there is at least 1 point. This one looks like the axiom that was talking about number 3, I think. If there is a space at least 2 points on a line, there is at least 1 point outside this line. So you see, there is at least 1 point outside this line. So here we are talking about in space outside a plane there is at least 1 point. So we are talking about the space, and since the space is containing not just 1 plane, so I'm sure that if there is 1 plane, however it contains what number of points, so there is at least a point outside this plane, because the plane is 2-dimension and the point outside is going to determine the 3rd dimension. Okay, a plane divides the space into 2 semi-spaces. This is the last axiom, saying that if you have a plane, then it will divide your space to 2 semi-spaces, not halves, it is semi-spaces. Okay, it is a type of division for space. Now on this slide we will talk about the position for any 2 lines in the space. Means that we have 2 lines such that these two lines may be parallel, and if they are parallel, so they must be contained in one plane. Now, this is the first case. Second case, that these two lines are in different planes, but the planes are parallel, okay? But the two lines do not intersect, since each one is in a plane that is parallel to other. And also, we will talk about the cases in some details. First one saying the two lines might be infinitely having many intersections. So I know that if two lines are intersecting in 2 points or more, we say they are coincident. Means that they have more than one intersection point. Of course, we can't draw it here because it is just one. In the truth, those two lines are one line in drawing. B, we have one common point, so if it is one common point, so they will intersect. So they are intersecting lines in one common point, and such lines that are intersecting two non-coincident lines with one intersection point determine a plane. And we said it previously, that two lines, when they intersect, they will determine a plane. But in case that they don't have a common point, so they may be in one plane, just like the parallel case, parallel lines, okay, they are coplanar because they don't have a common point, but they are coplanar because they are parallel. And another case such that they don't have a common point is the skew lines. The skew lines are two lines that are called skew lines if there is no plane contains both of them, such that this case here, they are skew lines because they cannot be belonging to one plane. Even here, skew lines, but here we have parallel lines, so they must be contained in one plane. And since we are talking about the space geometry, so we will talk about the position of plane and line. If I have a plane and a line, so the plane and line can be with no intersection, means that the line is parallel to the plane. Or there is an intersection with one point, and in case it is one point, means that the line is passing through the plane. And if it is already contained in the plane, so it is already belonging to the plane, means that it has many points, all of them are on the plane. So these are the three positions. Line lies in a plane here, or line intersects with a plane with a unique point, or line which is parallel to the plane.